Hello viewers, you are welcome to NECO TV, a channel that provides a solution to students who are offering chemistry and biology. In today's video, we are going to look at how you can solve NECO. This video is mainly for students who are writing a NECO examination coming out on Thursday. So we are going to look at how you can be able to answer it. The already endpoint has already been prepared. So we have 2023 NECO examination practical solution on chemistry. These problems have already been solved. So if you are a student, just subscribe to NECO TV and you get the question is already on the board. We are going to write the question on the board and then you use it and solve the various steps in which you can use and solve it is already written on the board. We are going to solve it as you join us. Just take a look at the question very well, see how it is arranged, and you see how the question that are being asked there. You see, A is a solution containing 0.040 moles per cube of tetraosulfuric acid. B is a solution of X2CO3 of 3.498 grams per cube. You should put A into burette and then titrate against a 25 cm3 portion of base. Then we have the equation there, and in the calculation what you are being asked to do is, number one is to calculate the concentration of B in moles per dm cubed. Calculate the concentration of B in moles per dm cubed. Number two is to calculate the concentration of A in grams per dm cubed. And the third one is to calculate the molar mass of X2CO3. The next one is to calculate the atomic mass of X. Calculate the atomic mass of X. And the last one is to calculate the volume of CO2, that is carbon dioxide, at STP that will be liberated from the equation. The volume of CO2 at STP that will be liberated from the equation. Remember, the volume of carbon dioxide at STP is given as 22.4 dm3, 22.4 dm3. So just look at how we are going to solve it and you appreciate it. This is how NECO will bring out their question exactly the way it is, because endpoint has already been determined. You just copy the table and you follow how the calculation is being done vividly. Like I said, that is the table of how your practical will look like. That will be coming up on Thursday. That is how your practical will look like. That is after your table. Just prepare this table. Have it in mind that this exact table that will come out after being tested, calculated, and practical have been done to ascertain the volume of acid. So we have the initial reading, which is 0.00. After your titration, you now calculate the average volume of acid. The average volume of acid, which is the average titer. You have the rough titer. We have the rough titer. We have the second titer. That is the rough, the first, and the third titer. You take the average, which is the volume of acid, 20.5. We have the 20.5. In the case of this one, we have 20.50. We have the 20.60. You have the 20.50. So when you take the average volume titer, you have 20.5. When you divide this one, at the end of it, you have endpoint of 20.53. So that is what you are going to use in your NECO practical exams. NECO practical exams, the endpoint is 20.50. That is 20.53. That is your endpoint. That is after being calculated using calculation method. For those who want to know more about how you can use calculation method to arrive at your endpoint without doing practical, it's just click on the comment section. Click on the comment section that I want to learn how to use calculation to determine endpoint without doing practical. You click on the comment section. If you are watching this video both in Nigeria, in Cross River State, outside Nigeria, you want to know how endpoint is being determined without doing practical, without doing the practical work, how to use calculation and determine endpoint. Just click on the comment section. Then I will respond to you. There is a video on that. let's move into calculating the first one. The first one will say concentration of B in moles per dm³. In the first question being asked here, remember these are the problems or the questions that you are going to expect in your exams. In the first one, you have concentration of B in moles per dm³. How do you calculate it? You use this formula CAVA all over CB VB is equals to mole ratio of acid is to mole all over mole ratio of base. So you are, of course, you know that concentration in of B in moles per dm³ is molar concentration. So you are looking for the molar concentration of what? B. Since the concentration of A is already given on the question. So if you make your B the CB the subject of formula, that is what you have. You solve it gradually. Of course, you know that CA is given in the question, which is 0.040 times the volume of acid. The volume of acid, that is the end point of acid, is 20.53 times the mole ratio of acid. From the equation, if you look at the equation there, the mole ratio of acid is to base. There is nothing yet, so the mole ratio is 1 and the mole ratio of acid is what? 1. So that is why we have the mole ratio of acid is to base is what? 1. So in divided by the volume of base, we use the volume of base is gotten from our pipettes that we use. Remember in the question they say that you should titrate it against either 20 or 25 cm³ portion of B, but in the laboratory we use 25 cm³ of B. That is why you divide it by 25. At the end you have your concentration of B is equals to 0.033 moles per dm³. That is the concentration of B. Like I said, where we have B is given in A is given in moles per dm³. That is why they are asking us to calculate in grams per dm³. Why the B, which is these are SCO3, is given in what? Grams per dm³. That is why they are asking us to calculate in what? In moles per dm³. And like I said, why we use this formula? There are two formulas used in calculating molar concentration. If you want to know more, you just subscribe to GMI TV. All these parameters have been explained in the video being produced by GMI. So, but here we have concentration of B in moles per dm³. That is why we use it. Remember, I told you that this concentration of A is gotten from this 0.0 in moles per dm³. And when you divide, you have your concentration of B as well 0.033 moles per dm³. The next one we are going to calculate is concentration of A in grams per dm³. Concentration of A in grams per dm³. In the second question, we have been asked to calculate the concentration of A in grams per dm³. The concentration of A in grams per dm³. Look at the solving here. In the concentration of A, what we are going to use is the formula molar concentration of A is equals to mass concentration all over molar mass. I repeat, mass concentration is molar concentration is equals to mass concentration all over molar mass. And of course, you are looking for molar mass concentration because concentration in grams per dm³ is mass concentration, while concentration in moles per dm³ is molar concentration. But since you are asked to calculate the concentration of A in grams per dm³, it means that you have to calculate mass concentration. So when you are calculating mass concentration, you make mass concentration the subject of formula. So you have to, what you are going to do is to cross multiply molar concentration of A times molar mass. That is why you have molar concentration times molar mass. But you know that the molar mass of H2SO4 is already calculated is 98 grams per mole. If you calculate, if you follow the step, that is how you see it. Then substitute it into the formula. Of course, we know we already calculate our molar concentration. The one we use as CAVA as in the formula, we had 0.039, and at the end of it we now have like I said, the concentration, the molar concentration we have in the equation is 0.040. 0.040. Look at, you go back to your question, you have 0.040 as your molar concentration of acid. You remember, all we are doing is of acid, we are not doing the one of base. So when you calculate that, when you multiply that, you multiply that by the molar mass, which the final answer here, you now have 3.822 grams per dmq. Remember, concentration, mass concentration is given in grams per dmq. So in the question there, at the end of it, we have our concentration as 3.822 grams per dmq. So we are not going to proceed to the next one. The next one is molar mass of H2CO3. Molar mass of H2CO3. So like I said, we are going to look at the third question. Sorry, the third question is to calculate the molar mass. Of course, we are going to still use the same formula. Molar concentration is equal to mass concentration all over molar mass. We are making molar mass the subject of formula. So molar mass now will be equal to mass concentration all over molar concentration. And the molar mass of what they ask us to calculate is H2CO3 is equal to mass concentration of this base is what we have it in the question. We have in the question there 3.498. That is the mass concentration. Remember, mass concentration is given in grams per dmq. Then all over molar mass, all over molar concentration. The molar concentration is the one that we have in our first calculation, that is CAVA. The one we use that formula CA. At the end of it, when you divide this one by this one, you have the molar mass of this of B is equal to 106 grams per mole. Remember, the unit of molar mass is measured in what? Grams per mole. So the fourth question we are going to look at is the atomic mass of S. We are going to look at the atomic mass of S in this question. We are still going to do the same thing. In the same thing, the atomic mass of S. We are only going to change this one. We are only going to change this one and say the atomic mass of X. So what we are going to look at now is atomic mass. We use this formula. Molar concentration is equal to molar mass. Molar mass now is equal to mass concentration over what? Molar concentration. And this one is equal to this. And at the end of this one, what we are going to do, we have 2x. We are taking this one to this side plus carbon here, which is carbon is given plus what? 3. We have 3 times what? O equals to 106. 2x now plus, see, carbon is 12. The atomic mass of carbon is 12 plus 3. Oxygen is what? Times 60 is equals to 106. And 2x now plus 12 plus this one times will give you what? Plus 48. 48 will give you what? 106. And 2x now plus, I hope you are following. 2s now is this one, add this one plus will give you what? 60. Is equals to what? 106. I hope you are following. So let's just wipe and continue here. So we now have to bring this down. 2x plus 60 is equals to 106. Of course, you know mathematics, simple mathematics. You want to make x alone. Remember, you are looking for the atomic mass of what? Of x. Atomic mass of x in this equation. This atomic mass of x. So we have plus is equals to, you have 106. Take this one to this side because what? Minus 6. I hope you are following. Then you have 2x is equals to, when you minus this one, you have what? 46. Then you are looking for x. So what will be your x? What will be your x? So your x will now be, you do what? You divide both sides by what? By 2. So 2x is equals to 46. Divide both sides by 2. Divide both sides by 2 so that you can free the x. So when you free the x, it will give you what? 23. Of course, if you have, this is exactly what NECO will give you, because it has already shown. using the titration, you discover that if you put this x now, for instance, let us try something that will amaze you. You discover that if you put this s as 23, of course, say s2 is equal to s2CO3. And if you put x there, x is what? 23. And what is the atomic mass of 23? Which element has atomic mass of 23? You discover that it is sodium. So you have Na2CO3. Waye will not give you this. Waye or NECO will not give you this. So that is why the prediction, if you follow Algebraic TV, is already predicted that this is the value that Waye will give you to find. Which, if you calculate at the end of our calculation, we have 23, which is what? Sodium. And it is this sodium that they will ask students to do is to find this, they will hide this, which will now correspond with this one. I hope you are learning something very, very interesting. So the last one we are going to look is the volume of carbon dioxide liberated at what? STP. I hope you are just subscribe to Algebraic TV and follow the video to anybody that is writing NECO. NECO is coming up next week. This video is taken on the 7th of July 2023. So before then, it is a 1 week interval. Before then, I believe that you have enough time to revise through this question. And qualitative analysis also in the video. You just go through all Algebraic video. You will see qualitative and volumetric analysis. We are going to look at the last one, which is the volume of carbon dioxide at STP. So in the last question there, the volume of look at the volume of carbon dioxide at STP. No, at STP, volume of carbon dioxide is always 22.4 dm³. So if you follow there, of course we know that from the equation, if you look at the equation here, H2CO3 will give you what? 1 mole of what? Carbon dioxide. 1 mole of carbon dioxide is because of what? There is nothing here. If it is 2 here, if you have 2 here in front of this C here, would have been 2 mole of carbon dioxide. But since there is nothing here, it is what? 1 mole of what? Carbon dioxide. Of course, you know in your concentration of B in moles per dm³, you have 0.033 moles of this will now give you 0.033 moles of what? Carbon dioxide. And of course, carbon dioxide, 1 mole of carbon dioxide at STP is equals to what? Is 22.4 dm³. And at the end, you multiply that by the concentration in moles per dm³ of B, and we now have 0.74 dm³. So if you have any question concerning this video, you should be able to put it on the comment section. I will attend to you. Thank you very much for all the viewers around the world. I'm so very happy for this opportunity. I just wish you just subscribe to Algebraic and spread the video to everybody that is writing NECO that will be coming up next week Thursday. Share the video and subsequent video on qualitative analysis. You just subscribe to Algebraic TV. All the videos are there. Thank you and God bless.